The last couple things in our notes that we want to notice here is that we're trying to look for the widest to narrowest. So we notice this one is definitely the widest, this one is second, and this one is third. So if we look at the a values, we have -4, we have 1/4, and this one is very slyly just 1. So we notice the smallest number that we have, if we take the absolute value, is 1/4, and then 1, and then the -4. Remember, the negative just makes it look like a frowny face instead of a happy face. Okay, so if we're talking about widest to narrowest, so as we evaluate these a values, what's the smallest number we have disregarding the negative? So we know it's going to be 1/3, and then 1, and then 3 for the widest to narrowest. So make sure you always read this part. It'd be really easy for me to flip-flop that. I'll try not to, but just make sure we're reading that. Next thing we have to do is take a look at what happens to our graph. If we plug in -2, we get 4. If we plug in -1, we get 1. 0 gives me 0, 1 gives me 1, and 2 gives me +4 again. So if I look at this graph, 1, 1, 2, 4. Alright, so here is that very first graph that we have. Now the next thing that happens is if I take and I do -3, so I'm going to get all the same values except for -3. So 0 -3, 1 -3 is -2, 4 -3 is 1. So we're going to take all these values and just move them down a little bit. And by a little bit, I mean exactly 3. Oop, should be up here, just a hair. So we plot these points. So you notice is this -3 on the end, right, this plus c, what we're after, is simply going to move just like a y-intercept, right? This means down 3 units. So that helps me move these parabolas up and down without having to make this table each and every time. Okay, so we know what the regular parabola is going to look like. And then if we use -3, that means down 3. That way we don't have to make tables every time, right? Because tables are cool to sit at and eat. But we don't have to make one every single time we do one of these. Alright, the last thing is we're going to find out how to graph these. So to do that, sorry, no other way to do it. Time is in place of our x, and the height is going to be in the y. So at time 0, what's going on? Acorn drops from a tree branch 70 feet above the ground, probably dealing with a squirrel. Right, so put in 0, -16, 0 squared plus 70. Alright, so we get 70 here. Or we can put in 1. Alright, so we're -16, 1 squared plus 70, so -16, that's 54 feet, 2, -16, 2 squared plus 70, and we start putting these over here. So -0, 1, somewhere around 54, 2, alright, we gotta finish that one up. So we get 4 times -16, 64 plus 70, so we're at 6 feet. Okay, 2, 6 feet. Alright, we plug in 3, we're going to end up in the negative. So when it says about what time, okay, we're going to be between the 2 and the 3. Okay, so between 2 to 3 seconds. Alright, so that's where we're at. So again, so quick review, axis symmetry, so jot something in here with what we have. Okay, so what type of line is that? X equals y equals. Parabola? What in the world? What shape? How do I know? Okay, what equation? Quadratic function. Okay, so we're used to this thing for a while now. The parent. Okay, so x squared. Okay, so what does it look like? What's it always going to look like? The vertex. How do I know? Max versus a min. So jot a few things in here to clear it up. Okay, and then in some quick little review, we're going to drop a coconut this time. Probably not a squirrel, you know? Just how it happens. And then we'll save these for a few things we could work on together.